Hi guys, welcome back to my channel. In this video, I'm gonna show you how we can make a Twitter hash search application with ESP8266. It's not gonna be difficult because it's based on a library made by a great contributor. Let's get started. We need a display to print the search results. I use the display ILI9341 with resolution of 320 by 240. The wiring was as above. In this project, it didn't have a touch function, so I didn't connect them. If you are using a NodeMCU, it's good to use the same wiring as me. If you are using a different line of MCUs, it's recommended you wire them in the manner used by TFT ESP8266. That's an easy way to run the display without any problems. We need to test the display first to see if it's working properly. There are the board and board settings that I choose. Only the basics are selected in Arduino IDE. There is nothing special. You need a library to run the display. I strongly recommend TFT ESP8266 library. This makes it possible to develop many things. Most of my projects using the display use this library. To use this library correctly, you need to modify the user setup header file for yours. Go to the Arduino library folder and then go to the TFT ESP folder, open the user setup header file with the text editor. You only need to modify what you need. First, leave your own display and comment out all other displays. I use NodeMCU, so this part sets the connected pin. Set the display and MCU to use and make no change to the rest. It's simple. Let's see if the wiring and library settings are actually working properly. Among the examples of the TFT ESP8266, there is an example source code of whether the graphics are output correctly. The links are described below. I will bring this source code and test it. I'm gonna change one thing, the serial speed. You don't need to change it if you see the raw console at the speed. Build and upload. You can see the graphics being drawn quickly. On the right side, I added the information about the currently connected display. By default, we will print text and a simple image, so this is enough. Let's create a Twitter application. Some keys are needed to fetch data through Twitter API. From now on, I will show you how to get these keys. Of course, you need a Twitter account to create it. Go to the developer.twitter.com. There is nothing on the screen because there is no app that has been created yet. Create an app here. Because I don't have any special purpose, I said this app is just to work around the API. Answer the basic questions. We do not use this app for authentication or tweeting, so do not select all of them. Finally, write briefly about what this app is like. It's longer than I thought because I have to write more than 200 characters. It's strict. On the next page, if you agree to the agreement, the app is finally created. There will be an email from Twitter in your inbox. Please verify your email through this one. Finally, we are on the Twitter development platform page. Put the name of the app in the field. I can finally see the keys, API keys and API secret key. But this is not enough. We also need the access token and secret. First, I will keep the API key and API secret key. You can get the remaining two keys from the project screen on the dashboard. Press the generate button to get the access token and secret. Let's keep this too. Now you have got all the keys you need to develop Twitter. Let's go back to the Arduino IDE. There is a library called Twitter Web API. This is great. This library makes it easy for us to call Twitter API. Without this, we need to make auth2 authentication to get tokens and call a specific API. It's gonna be a stressful job. Thank you for creating this library. Let's download this project and add it from Arduino IDE. Go to Sketch on top of the menu bar, include library and add that zip library. Select the downloaded zip file. We are ready to use this library. I'm gonna take the example source code and see how it actually works. Copy and paste the Twitter search example into your project. It's a pretty long code, but not that long. Let's figure out we know. The first thing is the Wi-Fi credential. Put your Wi-Fi's SSID and password. Currently, it's set up to find the keyword #dog. The update interval of the tweet is 20 seconds. I changed this to 10 seconds. Also, my time zone is PDT, which is UTC-7. Set my time zone here. Update your Twitter information. The API key that we have is a consumer key. Please change all 4 keys into your own. Let's see the dependencies. It's using NTPClient. If you don't have it, please install it through the library manager. Also, we need to have Arduino JSON version 6. Lastly, please install the time library by Michael Margolis. You can find it almost at the end. NTP, which is a network time protocol, is used to synchronize time between network computers. To briefly describe the structure of NTP, the NTP server, which is a server that provides time synchronization, must place the NTP server in the UDP with a 123 port. This is why there is a UDP in the code. Time is very important because of the validity of the access token. After a certain period of time, the issued token will not be able and you will need to reissue it. Because the Twitter library is doing for this, we can focus on the application level. In this example source code, it's using Arduino JSON to parse the JSON result from the Twitter API. I hope it's working fine. Let's print it out to the console to see the actual incoming data. Let me build it. Oops, this example is based on the Arduino JSON 5, so it cannot be built. So we have to make a JSON parser with Arduino JSON 6. Delete all this part and build it again. Now I can build it. Let's see what data comes in from the serial monitor. Update the time via NTP after connecting to a Wi-Fi. After that, it brings one tweeter with a specific keyword #dog. It fetches the data without any problems. Let's take a look at what data comes in. Copy and paste the part where the statuses are in the text editor. There's so much information in a single tweet. Since it's a JSON type, let's take a look closer. This is my favorite JSON viewer. Paste JSON string here. Then press the format button and you will see it neatly organized. Here you can easily see the field name and value. You can see it bring a tweet regularly. It's time to get our values from JSON. We will simply analyze JSON and extract only the necessary data. First, I will check the length of the message. If there is a problem, the length of the message does not exceed 1000, and in this case, just return it. Also, we must use dynamic JSON document. Dynamic JSON document allows storing much larger documents than static JSON document because it's not limited by the size of the stack. The reason for allocating twice the length of the message is the JSON parser needs more space than the length of the message. And when you create a JSON document, you also need to allocate a larger nesting limit. The structure of a tweet is more complicated than I thought, and default limit value is 10. If there is a problem when creating JSON document, the error is printed and returned from this function. For normal tweets, it starts with statuses, therefore make sure there is this key. After that, we can proceed with the normal JSON approach. For user information on this tweet, get the screen name from user in the zeros array of statuses. In the same way, you can bring in the contents of the tweet. Create a string to appear on the screen, including user information unless the context text of the tweet is empty. It's an @ mark, username, the word says, and then tweet text. If there is an error, parse and show the error results. After parsing in the main loop, print search message to the raw console. Let's build and check. An error has occurred. It says the operator in the string is not okay. That's because it's not using the Arduino string. Let's change it from standard string to the Arduino string. Rebuild it. No problem, I'm uploading it. Open the serial monitor. Let's see if the JSON parser works properly. You can see it works fine and the message is showing well. If it doesn't have any new tweets for particular keyword, you can see the same tweets as before. If you increase the update interval of the tweets, you will have always new one. Now that we have confirmed the JSON parser is working good, all we need to do is to create an output part of the display. It's similar to the part where the display was tested at the beginning of this video. After initializing the display, paint the screen black and set the direction of the display to landscape. 1 and 3 are landscape mode and 0 and 2 are portrait mode. I set the color of the text as white so that it can be seen well. Move the cursor where the first text will be entered. The first text to be displayed on the screen is Twitter #search. Don't forget to call this function to initialize the display from the setup function. I will apply another font to increase readability. This font is a built-in font for TFT ESP8266 and easy to apply. To see what free fonts are available, look at the free font header file of TFT ESP8266. It's simple to apply it. On the right, you can find the font reference you want. Let me create a function to output on the screen to view a simple string. Actually, you don't need it much. Just I want to see where it is before loading the tweets. Displaying the text Wi-Fi connected after the Wi-Fi connecting. After the time synchronization task finishes, display the text NTPClient. Show the text loading when it's ready to get the first tweet. It's showing all text including the status of the system on the display, so I will remove all status indicators using the built-in LED. Let's create a function to print the contents of the tweet on the screen. The first thing you need is to get rid of the previous screen by painting it black again. If you don't do this, it overlaps and looks weird. Also apply each font you want. For the hashtag keyword, I think the bold font is better. Move the cursor to print the hashtag keyword, and move the cursor again to print the tweet message. Call the show tweet function to draw the text on the screen only if the search message is made normally. Go to the loop function. We don't have to print the message and hashtag in the console anymore, so I delete it. Okay, let's build and check how it shows like. Here you are. It's showing system status text on the display. Good. And finally, the tweet comes into the display. It looks good, but I think we can improve it much better. Let's see what more we can do. As you know, the tweet contains the user's profile image. It would be better to show the user's profile image with user's tweet. The size of the user's profile image in the tweet is 48 by 48 pixel. This is a very small image, but it's a good size for my display. So I will use the default image as it is. The first thing to do is to bring the URL of the profile image, easily found in JSON document. I found it for you in advance from the JSON viewer. Alright, let's see if I really got the URL. You can see the URL on the console. To see if it's a valid image, let's copy the URL and paste it in the web browser. You can see the small image very nice. To verify the URL is normal, we will check whether _normal.jpg is included in the URL and proceed. Now we have the user's profile image URL. The next step is downloading it. Without downloading it in the file system, there is no way to draw it on the screen directly. A library is required to draw JPG images on the screen. Let's use another library from the creator of TFT ESPI. This is the TJPEG decoder library. This not only makes it quick and easy to draw JPG images, but also allows you to draw images from the URL. Please install it if you don't have it. Let's go to the GitHub in this library to get the files we need. Go to the example and web JPG. This is an example of downloading an image from URL to SPIFFS and appearing it on the screen. Let's copy the list SPIFFS header file to the project so that you can see the list of the files in the file system. You can download the file and put it in your project, or you can create and copy a new header file like me. Another file we need is to download images from the URL. Bring this header file into the project in the same way as before. If you look at the code, you know how it works. If your file system has the same file name, there is a code that returns 0 without downloading it. Even though this is good to prevent unnecessary downloads, I don't need this part because I plan to continue writing new profile images to the same file. So let me comment it out. Go to the main file. Let's include 2 additional header files just we added. Also include the header files for SPIFFS. Don't forget the JPEG decoder header too. The web fetch headers uses ESP8266 HTTP client to download files, so please change the Wi-Fi client secure header to this. I will have a character pointer for the user's profile image, including the file name and path to save in the file system. All profile images are stored in this file and images are loaded from this file too. I will bring the necessary parts from the TJPEG decoder. This is a callback function for rendering a JPG image. For SPIFFS to read and write files, it must be initialized first before using it. It's very common and I think you guys are very familiar with this, right? There may be files in the file system from the previous project, so I will format it once. This takes time, so I will only do it at the beginning of this project. Go to the part of the initializing display and add a few functions for TJPEG decoder. It has a part of the registering callback function that rendering an image on the screen that you added. Go to the section where you get the profile image URL. Write it down from this image URL to a predefined file name and path. I'll check the list of the files in the file system to see if it has been downloaded properly. If there is an image file, prepare to draw on the screen through the TJPEG decoder. There is one problem. Currently, this JPEG library can only be processed for baseline JPEG files. Unfortunately, other types of the JPGs cannot be read properly. So if it reads the JPG file correctly, the width and height of the image will come out normally. Otherwise, 0 will appear. I will check this part and decide whether to draw it on the screen or not. After formatting SPIFFS, let me print out the list of the files in it. I want to make sure of it. Let's change the hashtag. As a result of the search, the hashtag we want to place seems to be popular now. Build. Let's check it's downloaded from the URL. The file list should have been shown after it was formatted, but it wasn't. Also, it says file open failed. Oh my, I forgot to call the SPIFFS initialization function. Go to the setup and put the function init SPIFFS above init TFT. Let's try again. Okay, there is a delay due to the format. The list of SPIFFS files has been printed. It's been confirmed that there is nothing. But there is a new type of error, invalid input. Usually, it's caused by an input that contains escaped strings. I found a solution that they say changing JSON document to JSON object can solve this problem. All parts except the image were printed correctly. The image was also downloaded but didn't appear on the screen. The reason is the JPEG format is not baseline. Unfortunately, this part cannot always show your image unless the JPEG decoder is updated. For now, best we can do is put the placeholder image if the profile image is not readable. If it's working with the TJPEG decoder, then let's show it on the display. I'm downloading the user placeholder image from Googling. Open your photo editor. In my case, I'm using Photoshop. I'll change the size of the image to 48 by 48 pixels and save the JPG as a baseline. Okay, this is the user placeholder image I will use. I will create a folder named Data under the project folder and move this image into it. Return to Arduino IDE and upload the file from the tool via ESP8266 sketch data upload. If you don't have it, please download and install it through the link below. It has been uploaded without any issues. Create a file and path to the image placeholder in the same way as the previous user profile image file. Add the source code so that the placeholder image can be displayed on the screen. One thing is, I will grow the font for the hashtag keyword. It will look better. Let's check after the build. Yes, there is a placeholder image file. Good sign. I found one thing there. The image URL from Twitter has two types of the JPG. One of them is JPG and the other is JPEG. Oh, I didn't know that. We must modify the part that checks the containing string. I will change the routine to show the placeholder image first. If you do this, you will always see the placeholder image first. Finally, let's build and check the result. You can see it's working seamlessly. Unfortunately, it had been nice if there was a way to change the user's profile image to the desired type. I want to make many interesting applications with images, but it's still not easy to handle it on MCU. I hope there is a good way to do it. This project source code can be downloaded via the GitHub link below. That's it for today's video. Thank you so much always, and see you in the next project.